And then she asked me if it would have worked if we did electroshock to him, if we electrocuted him, because her understanding was that there's something in his liver that's sleeping, and if only you could wake it up, maybe it would work and it would cure him.
So I decided to make a couple videos explaining what mRNA is, how it works, how it could be used for a vaccine, for other purposes, why it's safe, and they just exploded online. And that fueled me to begin breaking it down and really trying to explain it in a way that felt very just human and conversational.
A lot of this is Latin derivative, which I think is totally stupid. And, a lot of, I think, the nomenclature that we have, the terminology we use is like intentionally made to be confusing. And I think there's history behind that, where we wanted to create some hierarchical divide between patients and providers. So we created this whole language. Welcome to Cracking Cancer, where we tackle the tough questions about cancer with real patients and world experts. Our mission is to empower the cancer community through education, bring transparency to the oncology system, and drive funding for critical cancer research. Whether you're facing a diagnosis, supporting a loved one, or simply here to learn, we're here to bring clarity, hope, and action to the fight against cancer. Hey everyone, and welcome to Cracking Cancer. I am your host, Dr. Kyle Concannon. I'm a physician scientist at the University of Colorado. And today joining me is Dr. Rob Swanda.
Hey everyone, so glad to be back here. I'm a science communicator. I help take complex science and try to make it simple for others to understand.
Thanks, Rob. And yeah, thanks for joining again today. And you've been a new big part of the crew. So I figured we'd take an episode and just talk about the importance of scientific communication from two kind of scientifically trained individuals. This is an episode where we don't have a patient on, because I wanted to have it just you and I together talking about what made us want to do this kind of work, the need that we found in the medical community, and just kind of go from there. So maybe just kicking off, we'll just get right into it. Like you trained at Cornell, and then you decided to go into medical communication. You have a PhD. So maybe, share a little bit about the decision to go from PhD trained into medical communication as opposed to continuing laboratory-based science.
Absolutely. I will say that my journey into science communication was definitely an accident, you could say. So I was doing my PhD at Cornell. I was studying how mRNA therapeutics can be used against renal cell carcinoma, a form of kidney cancer. And it was at that same time that I was wrapping up my studies that there was the COVID-19 pandemic that struck. And after a few months of the pandemic, we all began to learn that there was going to be vaccines distributed that were using mRNA technology. So even though that was in the vaccine space and my training was looking at mRNA therapeutics for oncology, still the same principles applied to that therapeutic and how that therapeutic would work. So I decided to make a couple videos explaining what mRNA is, how it works, how it could be used for a vaccine, for other purposes, why it's safe. And they just exploded online, and people really enjoyed understanding this from an individual who was directly working on it and almost demystifying what's going on inside of the lab. And it's funny because I feel like a lot of the analogies that I come up with, and even the work that I was doing at Cornell during my 5 years of my PhD, I learned how to communicate that by just talking with my family about the research I was doing. And I say the lab because that's what my grandma always refers to when I was going to the lab every day and doing my experiments. And she always wanted to know, like, well, what's going on there? And my family isn't trained in the sciences. They are unfamiliar with a lot of the terminology that I was using, but they were very curious. They would always ask, well, what do you mean you're doing this test? Or what test are the cells taking? Not like an actual test, of course, but they wanted to know more. They were asking curious questions. So it made me take a step back and say, okay, I've been doing these assays, these experiments for years now. So you know it like the back of your hand. But what about somebody who's just learning about it for the first time? It can be quite daunting, just like any field, right? Like I may be an expert in that particular experiment or assay that I'm doing for my PhD, but other people are experts in what they do in their day-to-day life. And it's typical that we ask them questions when we need help. So what about when people come and ask us scientists questions? How can we communicate that information back to them? So that was like the motivation that kind of got me into the training of how I can talk to individuals who are not trained in the sciences. And then after those initial videos kind of blew up online related to COVID-19 and mRNA, I just continued the information as more requests came in about, can you talk about this drug I'm taking? Can you talk about this disease state that I have or this diagnostic test that I have? And it just became this community of individuals who just continue to ask curious questions. And I tried to take that complex information and really just distill it down. So it made sense to an everyday person as they're trying to learn what's going on in the scientific world.
So I'm curious, to follow up. I think that's a great story, a great arc to get into this, and I'm not surprised that people ate it up. Especially with vaccines, which is a huge black box. There's a lot of mistrust around that, and just having some sense of what they're doing when you're injecting something into your body is really important. But there are thousands of people who are working on specifically mRNA vaccines. Like there are a lot of researchers out there, but for some reason you felt specifically compelled to break this down into an understandable way for the average person who doesn't have a big scientific background and put that out there for people to consume in one way or another. And I'm curious, can you speak a little bit about what drove you to make those initial videos? Like what need did you see out there that you were hoping to fill?
For me, the first video actually was a question that my mom had asked me. So she began seeing information on the news about mRNA vaccines, and she was like, well, what is this? They're saying that this is a form of DNA, or they're talking about that this has never been studied before. So it was these questions that were coming in, and totally fair questions to be asking, but they weren't coming in with the same background that I, could look at those questions and say, well, let's actually tease that apart a little bit, because yes, maybe this is the first therapeutic using this technology on the market, but this has been studied for decades actually. Or like people talking about, well, this is just a form of DNA, when actually, no, they're two quite distinct entities, right? So that fueled me to begin breaking it down and really trying to explain it in a way that felt very just human and conversational. If you've seen some of my videos, they're just really just me on a whiteboard talking about the mechanism, talking about analogies for people to understand the mechanism. And it's meant to really feel like I'm sitting there with you, maybe like, if you're watching on your phone, it's wherever you're at, right? So maybe we're watching it and you're on the bus on your way to a location. Maybe you're sitting in your living room and you're just on a break on a commercial for TV, right? So it's just any way that I could feel like we're just having this quick 2-minute conversation. That's kind of the goal that I always have with those videos, but stemming from the fact that I was hearing some of this, I wouldn't necessarily say misinformation at the time, but just the information was getting mixed up in the media and it was getting mixed up in the news just because everything was so new at the time that people didn't really know what to grab onto and what was true and what wasn't, because there was new stuff coming out several times a day. It was a fast paced, we were seeing these things being made in real time. So that was the initial motivation that I saw, was really just, okay, how can I break this down and educate my mom and, the surrounding family too? But then after I did that and they were like, oh, we get this. This was so great. I'm like, well, maybe other people will benefit from this too. And, posted it online and quickly saw that, yes, they did benefit from that information, and really latching on to the fact that, okay, people are trusting the information that I'm giving, or they're really being educated on the way that I'm communicating it. So how can we continue to build that education? And then I think that also helps to build some credibility, and it helps to build excitement around the scientific and medical fields as well.
Yeah, well said. I think all that makes complete sense. And I think it's interesting, 40 years ago, 50 years ago, the pace of scientific advancement wasn't nearly as fast as it is now. And so the difference between those who don't know anything about biology and those who are doing the research wasn't as great of a chasm. So I think now we're tasked uniquely with a much wider gap to cross. mRNA wasn't a routine term used until recently. And then for someone to have vaccines routinely, like all these things and our ability to make them in real time. These are recent advancements. And I think as the, I'll say academic literature, as science progresses, as we get more therapies, as we get more technologies coming out, I can see it all becoming incredibly daunting to the average individual who isn't trained in all this. I mean, I am an oncology physician. I treat cancers, and I know a narrow sliver of the whole research pie. And because I know that narrow sliver, I have a comfort, I suppose, around what I don't know. But it's not as foreign to me. Like I understand my piece in, and I know how to get additional information. I know that it is obtainable. But I think for the person who hasn't had really college level biologic science at this point, they hear these terms and it's like we're making it up. And I don't blame people for feeling that way. I'm just curious when you're approaching one of these videos, let's say the mRNA vaccine example or one of your mechanism of action for how a medicine works, how do you kind of square that? How do you try to get the person who doesn't have the same level of biology background that you do and catch them up to speed and then layer on top of that the actual thing you're trying to teach? Like, how does this thing work? How do you do that in a 2-minute video? What's your approach?
It's tricky. It's very tricky. I will say that usually what I try to do is focus on, first of all, the disease state in the first, say, half, right? So if we're talking about whether it's mRNA that's being used for a vaccine for COVID, or maybe it's some type of monoclonal antibody that's being used for a form of cancer, let's first talk about what is it that we want to protect ourselves from? Maybe it's an infectious disease. Maybe it's because we have a certain cell population that has a mutation and it's growing out of control. So let's establish that grounding first for individuals to really understand what's going on inside of the body, or what's going on inside of this infectious disease as it's making its transmission, before we jump into, now for the second half, how can we protect it? How can we stop it? So I usually try to outline what's going on. And then within that outline, usually there's going to be somewhere where it's like, this protein is interacting right with this receptor and it's causing inflammation, or it's causing uncontrollable cell growth. Well, then that's like a prime spot for me when I'm talking about the mechanism of action to say, well, when you have and you're treated with this drug, it's actually going to block that signal. So we just talked about how this protein is really important to move to the left and attach to this other protein. Well, when you have this drug, it's putting a wall in between the two. So they can't get there, right? So that's kind of trying to give some type of illustration on why the therapeutic is acting the way it does, or in the terms of some type of preventative, trying to talk about, well, we're giving an image right to the body to protect itself from whatever this infectious disease is. If our bodies are on the lookout for either a particular protein or a set of proteins, if it's a different type of vaccine, then it can give us a little bit more protection if we come into contact with the full-blown infectious disease later on. So it's usually a two-step, I will say. It's usually laying out the disease state and then laying out how the drug works in order to help others understand. And then, of course, as I'm talking about the mechanism of action, anytime I can put in some type of analogy, I will do it. Whether it's a lock and key, whether it's dominoes falling, anything I can think of that's like, how could someone visualize this as they're either listening to me or as they're watching me? I think that can be super helpful and useful for those who are listening/watching.
Yeah, and I think you're uniquely known for your good use of analogies, and how I think that's an awesome tool you use to make things understandable. Yeah, and I think I think it's interesting that individuals have very little background in the sciences. They approach one of your videos, and over a really short period of time, these 2 minutes, they can feel armed with at least some level of foundational understanding that when they're talking about this with a medical provider, a peer, they at least a little bit of light is shown in that black box. So I'm curious, when you make these videos, what is your hope that the patient or the person who's watching the video is going to take away?
Yeah, you absolutely nailed it. That's really what I'm hoping is that they'll just feel empowered if they are a patient or if they're a caregiver or they know someone who's affected by a particular condition or who may need to take the medication that I'm talking about. If they can feel empowered to bring that information to their care team, even just to start the conversation, that just makes me feel super happy. Or maybe they're just a curious learner and they're not affected by the medication, but they're just like, wow, this was cool. I learned something today. And maybe in a year from now, 5 years from now, they will know someone and they can direct them to that information or they can pass off some form of that information. That's huge for me. And then, I'm always interested though, like on the other side, right? So if somebody does take that information and they do feel empowered and they want to go talk to their care team, even if they're not fully grasping what's going on, even if they're like, hey, I just heard about this medication. I forgot how it works. It was too complex for me, but like I heard about this and it can be used for this type of cancer. It can be used for this inflammatory disease, something. If they brought that to their team, I think that's a win. But then I never know. So it's more of a question throwing back to you is if somebody comes to you with that type of information as an oncologist, like what do you feel or like what do you do when somebody does say, hey, I learned about this drug or I've been doing research on these different therapeutic areas. What do you feel as their oncologist in that time?
Yeah, when someone comes to me with some information that they've obtained themselves, either about a medication or about their disease biology, I love it. Because it shows me kind of a stable footing on which to build kind of continuing education throughout what they're going through. I think, and it's that whole framework was a big reason we started this whole podcast up and this kind of education series was, we do all these big trials. And the goal of a lot of these trials is to push the median progression-free survival or overall survival, meaning we want people to be on therapies for longer and we ultimately want them to live longer. However, the area under the curve, the other element of my whole job is making sure people have a good quality of life. And I think one of the biggest components of quality of life is having a sense of control. And part of that sense of control is having some sense of what's going on in your body. Particularly with cancer cancer is a disease biology that very few people really understand. And even those who study it have a healthy appreciation for how little we understand it. But when you come in and say, hey, I was researching this drug, well, great. Now I have some anchor where I get to say this drug. And a lot of times I'll go up on my whiteboard in my office, like in the actual clinic room, and I'll draw out the protein that we're talking about, and I'll draw out where the drug binds, what it does. And, this protein usually makes cells divide because it's, always on, it's always active, and it's signaling, and it's telling the cell to divide, and the drug blocks here. So, and then we look for a mutation here, and that might stop the blood. And so the principles are actually really simple. And the details are enormous and immense. And even us in cancer biology don't understand them. But we can usually dumb it down to like, you have this thing, we're hitting it with this, it no longer works. Like that's usually the extent of how complicated our disease biology is. So I love it when someone's taken the initiative to walk into that knowledge void, which is really scary because you have no idea. I mean, this is just a total black box. You have no idea what many of the terms are. A lot of this is Latin derivative, which I think is totally stupid. And, a lot of, I think, the nomenclature that we have, the terminology we use is like intentionally made to be confusing. And I think there's history behind that where we wanted to create some hierarchical divide between patients and providers. So we created this whole language. So when someone pushes in and tries to learn some of this themselves, even if it's just a little bit, it usually gives me a really good footing to take off from there and educate them more about their disease biology as we go, why we do repeat biopsies, why we're looking for resistance. A lot of this is built on even a 2-minute foundation, from a video like the ones you make. It really is a good anchor for us in the clinical world to jump off from.
That's awesome. That's so great to hear. And I think like one thing too that I always love to share, but also just encourage others who may be interested in doing something similar is that I don't think that there's like one type of communication that is better than the other at all, right? Like you never know what's going to click with someone. Mine are very whiteboard based. It's just casual conversation. It's, helping them understand mechanism, and it's me just talking to them. But you can do communication in so many different ways. There's people who do it with animations. They do it with just they're talking in the background and maybe they're drawing something out. I've seen people do things with science communication, and if they're talking about a particular infectious disease, they're actually like using like a plush, like a stuffed of that microbe, and they're doing something with it, right? So there's creative ways that we can interact with individuals who are not in the sciences field, and it doesn't necessarily have to be like one way. Like, oh, you have to speak to the camera, you have to feel comfortable on camera, you have to make videos or anything like that. I think that if you have these multitude of different angles that you can take, something is going to click with the patient, as long as they're feeling like they can have access to it. And that's also one thing that I like by making the videos and putting them online, is that for the most part, online is more or highly accessible. So therefore, hopefully it can reach places where maybe it is a lot harder to like get out to a clinic, or it is a lot harder to know someone who maybe is in the scientific or medical fields that you can just chat with. So using that online community, I think is actually really powerful.
No, I think that's great. And, I love how you focus on the accessibility. And I think I'd like to hear your thoughts, but I remember when I first got into the sciences and I was first learning laboratory skills and laboratory techniques, it felt like it felt really disjointed. It felt like when I was learning cancer biology that I was just picking up pieces of little things and it wasn't cohesive. Like you go from classes and there's a clear structure and you learn this and you learn this and you learn this and things build on each other. And then I got into cancer medicine and it was just like bits and pieces and I didn't really understand how it all came together for years. And then I just felt like I wasn't learning it right, or like it wasn't, and that made me feel really insecure. And I want to at least emphasize to the people listening that like that feeling is just what it is. Like you are not going to understand the foundations and the fundamental driving forces of cancers from YouTube videos and self-study, at least not for a while. But none of us do. None of us do from anything we do. It is bits and pieces that over time, you're creating you're filling in the pieces of a puzzle. It's a 10,000 piece puzzle and you're starting in random areas and you're just making little images that fit together. And then years later, you step back and you look and you oh, wow, this all came together. But the feeling that you don't understand what you're hearing in a full context, I don't want that to be dissuading to anybody. Like that is what learning this is. You get a little bit of foundation, you build on it, and then you learn a little bit more about something else that's complementary. And I think I love your videos, Rob, because they allow people to pick up those individual puzzle pieces together. And I don't think people are, it'll take a while before enough of that comes together where it starts to create the full picture. But you don't have to have a course in this. People can learn this themselves to the degree that they need to either advocate for themselves for their own care, be there to ask the best questions for those they love or themselves, and even advance the field forward. And I love how that's something that you were highlighting earlier, where individuals have really good ideas, I think, and they don't have to have PhD level training. They don't have to have, MD level training. They just need to learn a little bit of the language is all. Like the ideas are there already. They just need to learn some of the terminology to learn how to ask those ideas in the ways that we typically communicate. And I think your videos are a great way for people to learn how to do that.
Yeah, I think that the questions that people ask is huge in terms of what drives the content that needs to be made, because it helps me understand, well, what are people actually interested in learning more about? And then also like what's not clicking or what's not clear right now that still needs to be dived into more. And so I am a huge proponent of just being curious, like asking questions, feeling comfortable, like leaving a question, even if you hear something else and you want to know, like, if is what I just heard, even though maybe it's contradicting what you were just talking about, where is there a disconnect? And then maybe we can talk about it. We can talk about the different types of literature sources too. I think that's a huge thing that's broken also in discussions of scientific topics. I haven't really touched on it much, even in my own videos, but I know it's something we've touched about on the podcast before. But like, where do you even go to find credible scientific information? And how do we educate people on being able to get that? But then also, you can direct them to one place, but then all of a sudden, if they see like a paywall or something, it's like they're deterred away from trying to learn more. So there's definitely so much that can be done. We're not going to solve it in one podcast, but hopefully there's people out there who are also working on other avenues of this scientific information accessibility, because I think that that's another huge component of like when people do have questions and they're curious about it, how do we keep it going and not make them feel like they've hit a dead end just because there's things that are inaccessible, or there's things that feel like a hierarchy, as you said, that they can't even like go after and try to learn on their own.
Yeah, and I love how you mentioned the paywall stuff, which for those who don't know, our whole sphere of academic publishing, and if you're listening to this podcast, you may have heard that kind of the gold standard of publications is something needs to be in a peer-reviewed journal, which means, other individuals who are in the sciences read through your paper and they said, do this, don't do this, and this is bad, this is good. And then you do those changes they recommend, then they reject it, then you submit it somewhere else. And then, you go through this process and eventually it gets published. And that process is a vetting tool to make sure that crazy stuff doesn't get in. And 30 years ago, that was a really good vetting tool. In addition to that, you pay thousands and thousands of dollars for the privilege of it. So in order to get published in a journal, the person who is submitting the article has to pay a lot of money usually to the journal. And then the journal will charge more money to the people who want to read the article. So it is a big business. And because it's a big business, that means many other groups went to do it. And the quality of peer review has dramatically dropped at the lower end. So I think most people these days can get something published in a peer review journal somewhere. And do you agree with that, Rob, or am I just like totally cynical now?
No, I agree, because there's so many subtypes, I would say, of like specialties. So as Kyle was mentioning about the journals, there's usually like fields of journals. Like, so when you have something you want to publish, like Kyle, for example, would probably go towards something that's in some type of oncology journal, right? Hopefully. But then there's other, but then there's other journals that are focused on total different subsets of science. There's ones that are focused on environmental science, for example, right? So if you want to publish over there, but then within those, you get even more and more specific, as you mentioned, with like more journals coming out, right? So now they're super, super specific on maybe one certain type of cancer, I don't know. And it could be easier to say publish in that journal on like a lower end study. And I go back and forth when I talk about this term, and I'd love to hear what you think about it, Kyle, called impact factor, because I do think that there's things called impact factor that basically tell you how good a journal could be. Based on the fact that those papers in that journal have been cited more. If something is cited more, usually that means it's being put into more and more journals. Other journals are using that information in order to build their own stories, or take their information and contribute to a growing story. But impact factor isn't the only thing that can say if a paper is good or not, for sure. Just that's one thing that you can sometimes use to look at the quality of a paper. So a higher impact factor can sometimes be referred to as like, this took a lot more studies, took a lot more time, took a lot more effort in order to get into it, compared to a journal that has a very low impact factor. And that could also be just because that journal is new, so it doesn't have as many papers in there. So it's hard. That's why I said it's a dichotomy, because I don't like the fact that that's one of the standards you can use. but sometimes I don't know what else to look at.
Yeah, I mean, I love this topic. It's like picking colleges or something. It's you have the Harvards, and then you have the random rural eastern state thing. And I say that coming from Vermont and having gone to a state school in Vermont. So, I think people use it as a surrogate for quality, and often it is. Not always, but often it is. And it is, I think it's unfortunate because it's really hard to get into these high impact journals. And then people assume that because it's there, they assume because it's in one of these top journals that the science is 100% sound. And I'll tell you what, scientists are as biased as anybody. We're all human. We all have our huge blind spots. And it depends on who that journal sent it out to review, and do they know enough about the topic? Are they confident enough to say that they don't know about the topic, or do they not want the journal to know that they don't know enough about the topic? And then, how much time did they have if they're sending it out to the top researchers in the world? I happen to know those folks don't have a ton of time. So maybe they didn't do the best job reviewing as much as they would like to. So there's a lot of caveats that go into the assumption of quality when you're looking into a peer-reviewed piece. And I think to the low end of that impact factor journal, I'll say I get communications from peer-reviewed journals that just say, if you have a manuscript, we'll publish it. Just they look at my status in an academic center and they say, oh, we'll just trust that pretty much whatever you're going to submit to us is reasonable, and we'll put it in our next issue. So it is not hard to get something into a peer-reviewed journal. And I think there was a time where that was saying, oh, you really need this. And you still do. That is necessary. It's just not sufficient anymore. Whereas I think there was a day where I think just having that title really, really meant something. And that's why it's becoming increasingly important for, Rob, people like you who are going out there, and at least we're hanging our hat on the things you can trust, and we're narrowed in our scope of what we choose to talk about. And that's true, in the podcast here too. We're not going out in the weeds too much. We're not going out into the areas of, I would say, poor credibility or uncertainty. We talk about the ivermectin stuff. We've done the pembendazole episode. But even then, we're not making dramatic conclusions. We're saying what the evidence shows and what the evidence doesn't show. And, that is a one snapshot in time. It's an evolving thing. But people do rely on the stuff they find to inform themselves, and weeding through the varying levels of impact factor journals. It's just swimming in the dark in the middle of the ocean. I don't know how anyone's guiding themselves. You can find something to support whatever you want to think, because it is a business and people want publications. Journals want to publish stuff.
On the other side too, so do the scientists and the other professionals who are publishing, because sometimes even great papers are in those low impact journals. It's just because maybe it was a small study, or maybe it was just a quick study that was done by, say, an undergraduate over an internship period or something like that. It wasn't as robust as, say, some of these multi-year longitudinal studies that go into a high impact. But what that finding is could be revolutionary in terms of the way that it shapes the field. But 100% agree that there's benefits to both sides. Both sides are benefiting, the journal side and the people who are able to say, I have another citation, or I have another publication, add it to my list or my CV. And then they can use that to get more funding, get more grants, whatever it may be, and grow in the academic world.
Yeah, and I think, this is certainly a tangent from where I thought we were going to be talking about, but we happen to both work in this area. So it's just, we're grieving our feelings right now. But, I don't think people quite appreciate how the number of publications one has is a metric for your personal success. And that's what, if you're applying for grants, if you're submitting other manuscripts, they're just looking at, what did other people think of your work? Was it publication worthy? And if you can say, oh, I've published 10 things and whatever, even if they're not in high impact things, even if they're the kind of, I would call them chip shot papers, you do a finding, you submit it, you move on. That is a way to advance through, even if you don't really have strong, meaningful contributions. And I think that's a consequence of our funding structure right now, where safe incremental improvement is dramatically preferred over high risk, high reward, which actually moves the needle for the patient. But anyway, that's I think a digression from where we were hoping to go for people in medical communication.
But I guess just highlighting the challenge of a patient sitting down, doing a simple Google search, and they come across, a list of these PubMed articles, and they can't access any of them. That's got to be deterring for someone. And then if they see somebody who's written blogs and they're voicing their own opinion about something that's free, it's a lot easier, I guess, to say get like sucked into reading that just because it's accessible, because it's right there. So I guess that's maybe one way we can get back on what we were chatting about, because it's just, I try to, think about putting yourself in that individual's shoes as they're searching, because for us, or like if you are at like an academic institution, typically just because you're on their Wi-Fi, instantly it pops up, you can read it, you're good to go. But so we don't necessarily sometimes always think about, oh, somebody else isn't seeing the same screen that I'm seeing just because I clicked on this article link.
Yeah, and some of the things that are often publicly accessible are the abstracts, which are, for those who don't know, like we have several page long manuscripts, 10, 20 page long, and that's the paper, that's the research work in detail. And then there's kind of a cliff notes in the front, which is really a couple sentences that sum up the background, what you did and what you saw. And that is usually able to be seen. And the reason I bring that up is I think AI is doing actually like a reasonably good job of summing some of these questions up. Have you played around with asking nuanced scientific questions with whatever, Claude, ChatGPT, whatever?
No, not really. I haven't done much. Sometimes I've used it to try to find like an article. I'm like, I remember there was some article about this, and usually it can't find it. But no, I've never asked it to really like dive into some of like the nitty gritty of, say, a research article.
It's oddly good. Like, okay. I think when I've had patients come to my clinic and say, hey, I was researching my mutation using Claude or ChatGPT or what have you, and, is any of this right? And usually it's pretty spot on. Like, it sums up a lot of the academic literature, and you can tell it, dumb it down a little bit. I don't have a PhD or whatever. And it will do a pretty good job. So I think, as nervous as I was and still continue to be about relying too heavily on artificial intelligence to some complex information, it does have access to the full breadth. And as far as I can tell, it seems to do a pretty good job of separating the wheat from the chaff. It can get a sense of how many publications are in, the ivermectin cures cancer camp and how many publications are in the it doesn't do anything camp. And it'll say, oh, there's 10 for every one here. This is really where it's going to focus. So I think it does an outstanding job really for answering complex questions in a pretty easy to comprehend way.
That's great. That I guess in a way that's another form of science communication, right? If people understand it better through reading versus watching some type of video, there's, I guess for me, the only question is, or I wonder, is there some type of fact checking or community notes or things like that you sometimes, I think they started to be pushed out on some of the social channels within the past like 5 to 6 years, started to say like, hey, here's some additional information about what was just posted. I think even on X, or at least you used to be able to, like, if you were to retweet an article, I think it actually popped up and said, are you sure you want to retweet something you haven't read because you didn't click on the link? So there was like these almost just like little things that were in place to try to help encourage individuals to either learn a little bit more or to provide additional information. And just curious if AI will be implementing that, if they're not already, to provide that context.
Yeah, and I don't know the underworkings for its fact checking, but I can say when I'll play around with clinical questions because I know my patients are using it. So I'll put in, no identifiers, of course, but I'll put in like a general situation that one of my patients may be in. And I'll say, what would you do? And the answers it often gives are reasonable discussion points. It's not going way out in the left field. So I think if a patient has, they have a gastric cancer and they are progressing after their first chemotherapy, if they write their de-identified information in and give it a clinical scenario and say, what are some options? I think it's going to give reasonable discussion points to bring to the care team. And then you come armed with some things that, maybe your physician didn't know about a clinical trial that this thing's going to bring up. So I think, I've been impressed actually. It's not the way I thought my mind would go. I'm usually pretty conserved when it comes to this stuff, but I've been pleasantly surprised by how people can educate themselves and arm themselves with AI.
Awesome. That's cool. It's good to hear. I'll have to play around with it now.
It's different, it's different than like understanding what you do. It's not creating pictures and getting mechanism of action. It's not it's certainly not as entertaining. But yeah, I think it's one complement to a lot of the stuff we're doing. If the end goal is just to make sure the person goes in feeling armed and feeling equipped. One story that I'm not sure if I've talked on the podcast before or not, but a big element that got me into this was, I grew up in a rural family in Vermont in a low healthcare literacy family. And I had a brother who had a really rare genetic disease. It was called von Gierk's disease. And it's a glucose 6 phosphatase deficiency for those who, for the rare person who doesn't know what that is. What that is, your one of your liver's functions is to store sugar in the form of glycogen. It's like a Legos stacked kind of. And then what this protein does is it breaks them apart. So then your body can use the sugar. And my brother's body didn't make this protein. So sugar could get into the liver, it would get stacked up, but then it couldn't get broken apart. And my family, my father didn't finish high school and my mom didn't have any real formal education beyond high school. So like understanding the physiology of a rare liver disorder, a metabolic disorder, which affected him from an infant. He nearly died shortly after he was born. And then they kind of figured out what was going on and has to have, constant sugar, like every 4 hours, he has to have a complex carbohydrate. So he's always digesting sugars. But as a kid, like none of us had any idea how this biology worked. We didn't understand what the protein was. And even just the level of that I described right now was beyond the level we understood. Like we had the capability of understanding that, it just wasn't articulated to us that way. I remember going into med school and I had a call with my mother, and I was like, because we learned about this. This is a rare disorder, which is like what the med school exams are entirely about. They want you to learn rare stuff you're never going to see again as a weed out process, I think. But anyway, I learned about it, and I was like calling my mom up and telling her, actually this is how it happened. And then she asked me if it would have worked if we did electroshock to him, if we electrocuted him, because her understanding was that there's something in his liver that's sleeping. And if only you could wake it up, maybe it would work and it would cure him. And to me, like my brother at the time was, 30. So my mother had been wondering this question, which she knew was like not a good question to go into the doctor's office and ask if I can electrocute my child. Like, so she had the wherewithal to not voice that. But if she did feel comfortable, going forward with that question, that's like 30 years of wondering, could I have helped my child? And that anxiety or the fear or the wondering, could I have helped my kid, would have been alleviated decades ago. And this fun, like this very, very fundamental understanding of what was going on, would have made a world of difference. And I think, one, she didn't have the internet. We take that for granted now. But two, the comfort and this feeling that because she didn't speak as elegantly, as perhaps I speak now, because I've gone through the medical training and from rural Vermont and kind of spoke like that. And that difference between the healthcare providers and us just felt so big, and we felt so inadequate and dumb, and we didn't want to question them, and we wanted to be really respectful of their time. We were just very impressed by them. And it just seemed that such a small just a small change in someone's understanding could have, helped this woman, could have helped our understanding of the disease for decades. And even, there was a time when he was really, really sick and he was intubated, he had a breathing tube in and he was on, life support. And we didn't understand the disease biology. So we didn't really understand what was going on. We knew he had an infection of sorts, but we didn't know why was it this bad? He had appendicitis, but appendicitis doesn't usually, kill kids. And so we're a religious family. We just prayed a lot. And I remember, I'm still a religious person. I still believe in praying. But there it was because we had no other avenue. We didn't understand it. It was just everything felt totally out of our hands. And I remember going through med school and then feeling so much better equipped to rationalize what was happening. And even if I couldn't control the outcome, understanding that this infection leads to this course is treated by these things. And if this doesn't work, then the patient passes and you can at least see the map ahead. You can at least know the road you're walking. But when you're not equipped with any of that baseline knowledge, it just felt like walking in the dark, and everything was so scary. And I remember how empowered I felt after going to medical school that maybe I can't change the outcome for my patients, but helping shine a light on the path that they're walking is a huge factor in their feeling of how they're living with the disease. This is a big part of morbidity. We talk about mortality a lot, how long someone's going to live, but what's the quality of life that you're living in that time? And I think coping with the fear and the sense of uncertainty and a lack of ability to understand your disease course is something we can combat. And obviously I commend you, Rob, for doing that in the very approachable way that you do. And hopefully we continue to do that here. We can't always change the path that someone's going to walk down. People are going to die of cancer. It's going to happen. But we can help them make sure that they don't feel totally alone and they don't feel lost, and that's part of what I think we're hoping to accomplish here. And I was thrilled when I saw your work and you wanted to work together, because I think we're totally aligned there. But yeah, that's a story I hadn't told before, I think, on the podcast. But I think, it just speaks to the importance of proper medical communication now. Especially our visits are really short. We don't have the time to go through all this.
Yeah, no, I think what you said was beautiful. And I really hope that other physicians feel the same way of shining that light on the patient's path. That is just, that's a goal that needs to be framed somewhere, because I really do think that, that would be awesome if so many physicians felt empowered to do that, to help the patients as they're coming in. And I think many do. I've met so many, as we've gone to these different conferences, as even I've gone to the doctor myself, I feel like there is a shift, or people are helping the patients and the families better understand, and there's different resources available, but there's always room for improvement. There's always more that can be done, I think, especially even in certain areas of different diseases. Some diseases get a lot more attention than others. And is there a way that we can help bridge some of those gaps, especially when it comes to things like rare disease, help people understand what's going on? So hopefully this is making an impact, and on not only, as we said in the beginning, the patient feeling empowered to go to the physician, but also the physicians feeling empowered to communicate and listen and try to break things down during those visits. But as you just mentioned, they're really short. So,
Yeah.
where else is there room for that to fit in? I don't know.
No, and I think your videos and a lot of the other content that's out there around this sphere, this world of cancer, is a huge compliment to the physician. And having trusted resources that people can go to helps us so much. I get a lot of communication from patients who say their physician isn't interested, or they just come in, they do their job and they leave. And I know what it's like on the other side of that when you have 3 people waiting, like in rooms right now, and 2 are progressing, and you have to consent them for treatment, and you have to talk about the treatment, and then the next person's going to be an hour late, and you have all these things, and to be able to sit down and make sure they understand the disease biology will often run second to someone getting a life-saving treatment they need. And I think it's so helpful when someone comes in and they've done their own investigations and they've gone through these validated channels, and they already know those foundations. They already know the fundamentals. They've taught themselves the terms, and then it makes the visits go so much more smoothly, and we can really talk about the different treatment options they have in an informed context, where rather than spending a lot of that time on what is chemo, how does it work differently from this therapy, how does it work differently from this therapy, if the patient already had those, and I'm doing the same 2-3 minute kind of spiels on each one that they're getting with your kinds of videos, maybe not as elegantly, but but then that 10 minutes is now spent to just, what should we do? That adds up over time. That is a huge, that's a game changer, I think, for the patient.
Yeah.
All right. Well, I think we probably beat the benefit that we hope to derive from the medical communication that we give. Is there any advice that you'd want to give to the patients listening about their own journey in seeking medical information before we cut loose?
I just say, just keep asking questions. If there's things that you don't understand, feel free to reach out on the videos that I make. I think that there's many creators who are in the scientific community who would also love to make more content on what you're actually interested in. I know for me, they say not to do this, but I look at every comment. So I really do try to pull the information that people are interested in. Usually it's not like a direct, like, you're going to answer via like a DM sometimes, or like try to give like these lengthy answers. But if it's a topic that I feel like I could make a video on, like hopefully I'll have it out but in a couple months. So I just say, be curious, ask those questions, and go in feeling empowered. And I guess it's almost like taking ownership of your health and your journey, because as Kyle mentioned, like hopefully the doctor or the physician will help shine that light on the path you're taking, but you ultimately are the one taking that path. So try to be as informed as you can and be curious.
I love it. Nothing else to add. Well, thanks, Rob. Thanks for taking the time to join us. And I look forward to more of your videos coming out. And everyone, you can have requests for the kinds of stuff you want to hear us talk about at crackingcancer.org. And we will catch you next time. Bye, everyone. Thank you for joining us on this episode of Cracking Cancer. If you found this helpful, please like, subscribe, leave us a review, and visit crackingcancer.org for more information. Every dollar we earn goes directly to furthering the podcast and supporting vital cancer research, because together we can crack cancer.